Welcome to my presentation for NRM 638 GIS programming. My name is James Shoemake. For my final project, I have designed a suite of custom tools that can be used to reprocess or update a GIS database that I developed as part of my master's thesis. Currently, this toolkit includes 3 Python scripts. The first script tool will take a polyline shapefile representing daily herring spawn, add a user-specified date in a new date field as well as a short integer count field, and will dissolve multiple line features into a single multi-part line before joining it to a shoreline template based on NOAA's ShoreZone database. Here we have folders containing 12 years of spawn data. Each day of active spawn is its own shapefile. The end goal is to consolidate these down into a form that can be queried and analyzed using attributes from the master ShoreZone database. Adding dates and performing a spatial join is the first step in this process. First, the user inputs the daily spawn map, the spawn date, selects a predefined search radius for the join tool, and inputs the ShoreZone template. The tool will automatically search the folder and create subdirectories for storing the processed layers. Once the tool is finished running, the user would check the ShoreZone shapefile and edit for quality control purposes before moving on to the next tool, which will combine each day into a feature class representing a single year. Running this tool in batch mode allows for an entire year to be run in a single go. After running the converter tool in batch mode, we are left with 2 new subdirectories, processed and ShoreZone. The second tool will take the ShoreZone subdirectory and compile each daily feature class in that directory into a single feature class representing an entire year. It will save a copy of this consolidated shapefile to a specified geodatabase. The user inputs the ShoreZone template, the folder location containing the shapefiles to be processed, the spawn year, and the location of the output geodatabase. After running the geodatabase, we'll have a feature class called spawn_date_ and the year, which will contain multiple fields corresponding to each day of active spawn. The third tool is exactly like the second tool, only it's designed to create a feature class that counts the number of days of a shoreline received active spawn. Once the tool is run, we have 2 feature classes in our output database, one for spawn days and the other for spawn count. If we take a look at the attribute tables for these 2 feature classes, we see that each shoreline in the data set is identified by the days it received spawn and by counts for each of those days. With the spawn counts, we can tally those up to determine how many total days of active spawn a stretch of shoreline received. This concludes a summary of my tools.